Hi everyone, we're going to learn about the real world applications of functions today. So in this first exercise, we're going to start off by looking at this graph, understanding what it means, and answering a few questions about it. So the problem is Jeremy heads out to school by foot. His distance from school in blocks is given as a function of time in minutes. He has been walking. The function is represented by the graph below. So our x-axis represents the number of minutes. Our y-axis represents the number of blocks he is from school. And the total graph, the title of it is Jeremy's distance from school. So the first question is, how far does Jeremy start from school? So we need to look at when the time is 0 because he starts off at home and he goes to school. When the time is 0, if we go up to where the graph is at 20. So that means when he's home, he is 20 blocks from school. What is his distance from the school after he has been walking for 5 minutes? So we're going to go over to 5 minutes on the x-axis and go up to where the y hits the line. So the y hits the line at 13, which means after 5 minutes, he is 13 blocks away from school. After walking for 5 minutes, he stops to make sure he packed his lunch. So if we go to the 5-minute mark, we see a point there. How long does he stop for? So we see the line is straight. It doesn't go up or down for 1, 2, 3, 4 minutes. So that means he stops to check his lunch for 4 minutes. Jeremy then, after he stops for 4 minutes, walks to the bagel store before heading to school. How many blocks did he walk to go to the bagel store? So we notice his number of blocks from the school goes up a little bit. So that means he walked 1 block because it goes up 1 number. Did it take for him to get to school once he left the bagel store? So that ending dot there, after he goes up for 1 block, is where he ends up, and then he has to travel back to school. So the distance between that point and the last point in the graph at 0, we have the first one at 11 minutes, the last one at 16, so it takes him 5 minutes to get to school. Exercise 2, we have a water tank is being filled by pumps at a constant rate. The volume of the water in the tank V in gallons is given by the equation. V of t equals 55t plus 260, where t is the time in minutes the pump has been on. So part A, at what rate in gallons per minute is the water being pumped into the tank? So rate is essentially the same thing as slope. So we have to look for the slope of this equation. The slope is always whatever is in front of the variable. So it's 55. Whatever is next to the variable is the rate. So it's 55, or in gallons per minute. How many gallons of water were in the tank when the pumps were turned on? So essentially that's another way of saying what is the initial amount. Another way to talk about the initial amount of something is the y-intercept, or the constant. The y-intercept, or the constant here, is 260. So that means initially there were 260 gallons in the tank. So essentially if we take apart this equation, we have 260 gallons to start, and for every minute, we have 55 gallons being pumped in. Part C, what is the volume in the tank after 2 hours of the pumps running? So what we need to do is take our original equation, and we're looking for 2 minutes. Time represents minutes, so we're going to plug in 2 for the time. So we have 55 times 2 plus 260. 55 times 2 is 110 plus 260. So 370 gallons are pumped in the tank after 2 minutes. So now we go on to part D. The pumps will turn off when the volume in the tank hits 10,000 gallons to the nearest minute. How long does this happen? So now we're given that volume and we're looking for time. So we're plugging in 10,000 for the volume. We're looking for the number of minutes. So we have nothing to plug in for t. That's what we're solving for. Now we're going to treat this like a two-step equation. So we're going to subtract 260 from both sides. So we get 9,740 equals 55t. To get t by itself, we divide by 55. And this is actually going to get us a little bit of a crazy decimal. We have 177.09 something, something, something. But it asks us to round to the nearest minute. So we have 177 minutes it takes to fill up the tank 10,000 gallons. Now we're going to flip over to the back side. These aren't essentially word problems, but this is something you still need to know. So anytime we have a function written like this, what this means is this f of x over here, this is another word for the y, or the output. The input is whatever you plug in here, and you also plug in here. So for example, when we have x of 3, we're plugging in 3 everywhere we see x. So we plug in 3 there. So the equation is x squared minus 1. We plug in 3 instead of x. 3 squared is 9. 9 minus 1 is 8. So that means f of 3 equals 8. When the input is 3, the output is 8. Let's look at 0. So when we have f of 0, all that means is we're plugging in 0 everywhere we see an x. And for the rest of these, all we're going to do is plug in those x values and solve. So for -3, all we're going to do is plug in -3 for x, and we solve. 0.5, we plug in 0.5 for x, and we solve. B is a tricky one. All you're doing is plugging in b. It's a variable, so you can't solve it anymore, so you leave it as b squared minus 1. For 1/2, all you're doing here is plugging in 1/2 for x, squaring it, subtracting 1. And there are your answers.